Today's slides, today presentation, I'll talk about some of the tips on performance, but also I'll talk about some of the concepts, kind of in a low-level concepts about how computer works in general. So you understand that these tips are like from where are they coming from. But today presentation, unlike the previous one, it's a bit technical, like actually quite technical. So for some people from non-technical background might not understand the whole concept, but I'll try to simplify it. All right, so today agendas, I'll talk about memory management. I'll talk about ORM, since the ORM usually the bottleneck with the backend applications. I also talk about some of the tools like profilers, and finally we'll have EQA. Today I was planning for more agendas, but didn't have much time really to put these, especially the slides. And since there would be actually code too, so I couldn't put more subject to this one. So first I'll just talk about memory management, so you understand that how actually high-level programming languages like JavaScript, Python, like Ruby, C++, and C, even Rust manages the memory. Because memory, every application, every program needs memory. Actually, all they do is memory. Because the data, they don't live on the code you write, but they live in the memory. They don't even live in the CPU. The CPU reads data from memory once it needs to execute the code, but it's always in the memory. So it always, your application always uses memory. Usually, if you have a lot of data, you'll have bottlenecks with the memory, and reducing the amount of memory you need and the amount of copying of the data will speed up things, but you might not notice them, especially when you're working with high-level languages. But it's important to understand. So there are actually 5, but I'll talk about 4 today. 4 type of memory management that programming languages use by design, by default. So the first one is the manual memory management. Basically, this is sort of it. The programming language doesn't do anything when it comes to memory. So it lets you, the developer, decide when you want to use memory and when you want to remove. Basically, these terms, if you want to get some memory, we call it allocate. And when you want to remove some of the memory that you're using, it's called free. So it's allocate and free. So in manual memory management, it's just up to you. You could ask for 4 gigabytes or could you ask for 8 gigabytes, up to you. C it doesn't have, it uses manual memory management, but C++ as well, because it's built on top of C, so it uses, but C++ has its own a new way of handling memory. The other one, which is the most popular one, is the GC, the garbage collection. Now, in every programming language, now the high-level one like Java, JavaScript, Kotlin, C#, every one of these use garbage collection. Basically, you don't deal with the memory. You actually don't know how it works. I mean, you don't know when it's doing memory allocation and when it's freeing. Basically, the garbage collection is like a background job. It runs every single, let's say, second, or depends on the implementation. There's many implementation, but it's like a background job that runs it's a scheduled job that runs, let's say, every 2 seconds, 3 seconds, or maybe 1 second, depends, right? And sees which are of the objects or which are the values that you you're not using anymore in your code, and it will free that. Now, that is the reason why, for example, these programming languages are slower than, let's say, C or C++, but there are other reasons, but that one of them. Some of the time you have bottleneck with the garbage collection, like a spike. Because the garbage collection runs with your application. It's not separated. So it's something like you have like a child process that is always running with your application. So this is the most popular one. Most of the languages use this one. That's why when we use JavaScript, for example, or I think Dart the same, Ruby, all of these, we don't allocate memory and free them. Another type which is introduced by C++, it's resource acquisition is initialization. Basically, because C++ introduced classes, so they say if you create a new object, once you stop using it, it will get freed by itself. So they allocate memory with the keyword new, and if free it once you stop using it, when it goes out of scope. The last one, which is kind of the newer one, it's called ownership, which is introduced by Rust. Rust is the only programming language that has this ownership memory style, memory management style. Basically, it'll check if let's say an object or a variable, it always should have one owner, and once the owner goes out of scope, the child or the thing that the owner uses will just get freed as well. All right, so I'll try to show you the manual management, because garbage collection, you're already familiar with it. It just works in the background. You don't have to think about it. It just runs. And if you use JavaScript or any other language, it will use. But for memory, for the manual one, I'll try to show you. By the way, if you have questions, you ask immediately. You don't have to wait to the end of this meeting, because some of the questions might be, you might forget about them. But if we open up, if we try something in C, turn 0, right? If we have int 8, let's say it's a 32, so my age is 32. Now I don't have to, so I don't have to allocate this. The program will put this in the memory by itself, because this is yeah, I should talk about something before that. I think it's too early for this one. I'll talk about stack versus heap, and you will understand how the memory management works to this one. So the stack and heap, both of them are not hardware. In your memory, there's no physical physical component or a chip called stack. It's a software running by the OS itself, by operating system. Every programming language has a stack. Basically, if you ever encounter an error, it always print the stack from the top to the bottom of where are the functions and where you get the error. So every programming language uses stack. Stack is if you remember from the university, it's last in, first out. So that's why the programming languages uses them. They use them because of how it works from a software perspective. So all the types are the primitive type are stored in the stack. For example, if I define an integer, if we go to this slide, if I define an integer 32, this one will be on the stack. Same goes if you have avoid create user, right? And you define a username. No, like char username, right? Admin. This will also be on the stack. Why is on the stack? Because it's in this function. This function, it's a scope to this function. It's not going to, you can't say username here, right? If you want to print f this one, oh, right? Yes. So if you can't, this is like undefined because it's defined in that function, so it's scoped to that one. So the programming language will add a sort of, the stack is like a box. So first will be like the main function, right? And the main function has age, and then we have a create username. The username the create user has a variable called username. And so first one, it goes to the stack, goes the main, then the age, and so on and so forth. So once you return from this, which this function doesn't have return, but once you finish from executing this function, the username will get removed, will pop from the stack. So you'll pop this. But first we push these to the stack, and once you execute them, you pop them out of the stack. And same goes for the function. And then after that, the age, and after you finish from the main, it will pop out of the stack as well. So all of these are the same on the stacks. The problem with the stack, first, the stack is so fast to allocate, to put things on, because all you have to do, imagine the stack, it's like, let me show you. Where is this? Like imagine you have something like the stack, it will be like this. So you are like here in this one, and you push the main, right? And if you want to add, you just move the head. So you move the head. So this is like, let's say 0, and this is like 1. You move the head plus 1, and then you add the other thing. Let's say age. Sorry, I can't do with the mouse, but you get the point, right? If the stack look like this, every time you want to put a new variable, you just move the head of this one to the empty position, and then you add the new variable. So it's easy to allocate. You don't have to check how much in the stack, or where you are at now, or whether you have memory or not. So it's much faster to do allocation on the stack. Also, multi-threaded applications, they will have different stacks, so each one gets stack. This is where you encounter something like Stack Overflow. Oh, that's where is the website coming from? This is error coming from if you have a lot of variables, because stacks have limits when you run your application. For example, if we try Node, if you ask Node.js how much the stack, it's almost like less than 1 megabyte. So this is the stack. Of course, you can change it when you run your application, but that's the default stack. Right, so that's why you get something like Stack Overflow errors and stuff like this. But other thing is, the memory management is done by the OS itself, not the programming language. So the C does not do the push and pop by itself. The operating system will do that for you. All right, so that was the stack. Now let's talk about the heap. Now the heap doesn't have really limit. It's like as much as you have memory on your machine, on your machine, it will be basically the size of the heap. But sometimes you can get, you run out of memory if you use the whole, the entire RAM. It's done by the programming language or manual. For example, if you have a manual memory management style, you will do the allocation by yourself. The heap is shared among threads. So the data that have dynamic size that you just don't know when you compile the code will be on the stack, on the heap, because if you want to allocate on the stack, you should know the size of the thing you're dealing with. But if you have, let's say, array or like a response from the API, you're not going to put that in the stack. First, because it's too big. Second, you just don't know the size of it, so you can't put that on the stack as well. And it is slower. Why is it slower? Because when you ask for memory, the program will ask the operating system for some memory, and the operating system goes and check whether you actually have memory and whether application can get, because on the computer, not only your application running, right? There's other applications. For example, I'm using now a lot of applications. Now, each one of those has its own memory, so you can't just take from other applications. So the OS has to do its own jobs. That's why it's slower compared to stack, because as I talked about stack, it's just a matter of moving the cursor to 1 plus 1 or minus 1. That's all you have to do. Now let's look at how we do this in C if we want to allocate on the heap. For example, I want to first I'll show you how to make an array on the stack. So I have like array on stack, and it's like a 3. 1, 2, 3. Right, so this one the OS will put basically this array on the stack. I don't have to manually allocate this one. And once the main function execute, these both variables will go out of scope. Now, if I want array on the heap, I'll have to do array on heap. And it will be, I'll have to allocate it manually. So to do this with C, you have to call malloc or calloc, any one of these. But that's how you allocate memory. So size of integers is I want array of integers, and let's say it's array of 5 or 3, same as the above one, but this one on the heap. Now I get, this is a memory on your computer, right? And you could do anything with it. You could do the same thing. You could do 0 and you assign it same as the above, exactly the same thing. And it works the same way, but the difference is now when the main function goes out of scope, this will get removed from the stack, but this one won't. So because here is manual memory management, so you have to do it by yourself. To do this, you do free array on heap. Now, if you forget to do this, you will have memory leak, and every time if you have a lot of functions, could application keep leaking memory, but that's how you free. Same goes, for example, if I want to return array here. Let's say I have this type div struct. I have user, right? I have ID, int ID, and char star first name. And this function return a user. Now I don't want to put the user, I don't want to put the user, let's say, on the stack. So I want to allocate the user on the memory and then send it back to the code that calls this function. So I do the same thing, but this time I'll allocate for user. So this is user, and size of, instead of n, this will be user and just one. And now I could user dot first name and assign the user. ID equal 1 and return user. Now this is allocated on the heap, and if you want to create one, you call user, or like this is admin. Create user, and here is admin. Right, so this is a pointer to the admin. If you forget to free the admin, because now it's your responsibility to free, not the responsibility of the create user. Create user function will not free because it can't free, right? It must return the user to the caller. And so you have to do same as one, but this one with the admin. Now, this is like the manual memory management in C. The difference is when we talk about C++, like resource acquisition is an initialization, is that C++ have classes, and they have like public thing, and they have it's a class called user, and they have like constructor, and also they have something called deconstructor. And you hear like initialize the user, right? And here is like deinitialize. And in C++, they came with the word, so this is admin2, right? They come up with the word in new class, and you pass whatever data you want here. Now, in new actually does malloc behind. But the difference is, you don't have to do malloc, and you will do it for you. And other thing is, you don't have to do free, because the deconstructor will call free for you. So you don't have to think about it. Once you allocate something, once it goes out of scope of the main, they will the program C++ will call the deconstructor, and the object will get freed from the memory. So that way C++ uses that, how it works. And Rust also uses this idea, but with the ownership. And garbage collection, basically, you don't have to think about all of that. It just happens behind. But now here is the point that I actually want to show you after I talked about all of this. Now you understand the heap has overhead when you want to allocate, when you want to free. So V8, so JavaScript is not a compiled language, it's interpreted language. So in order to run it on the browser has an engine that reads your code, your JavaScript, and then run it. And on Chrome, it's called V8. V8 Chrome. Basically, this is the engine. It's open source. Even on GitHub, you can GitHub. But you could look at the code and see. This is V8. The engine runs in the browser, because the browser is just an application running on your desktop. It has a lot of things. And it's written in C++ and also a lot of stuff, but manually it's mainly in C++. So all the allocation, all the freeing that JavaScript does. C++, C++ does the same stuff that I just show you here, and it allocates and deallocates. So once I talked about this, let's look at something here. Memory. All right. So this is TypeScript, right? So this now you will have much clearer understanding that. So you can see here this function. This function take a machine, right? The machine has sensors, and it's basically count per status, right? So it counts the idle, how much sensors are idle, how much sensors are active. Now, if you look at this code, can you tell me how do you improve this function? Does anyone know how to improve this function, and what are the thing that you could have done better? มีใครรู้ไหม how to improve this function? Yeah, so okay, I left a note there. So yeah, so but does anybody know? Since I already talked about the memory,ไม่มีใครรู้หรอ Okay. So the thing about TypeScript, since I talked about TypeScript and its uses, forget about TypeScript, JavaScript, because TypeScript is just a lint, right? JavaScript will be run on V8, and it uses C++. And even if you use Node.js is actually based on V8, right? Node.js is just V8 with event loop, which will be out of this scope. But since JavaScript uses V8, the problem with this is how do you improve this function? First, the function does not use machine, but only uses sensors. Right? So imagine if machines have maybe oil data, like oil or maybe operators. Or could other I don't know, parts or other there could be a lot of data. But when you're passing it to this function, the function doesn't use these data. The function doesn't need any of this. It just needs the sensors. So first thing you do is instead of this, you just pass the sensors. Right? Sensors. And this is, no, this is an array of these things. And now we get rid of this one. Now, why that was a problem? First, because every time you pass to a function, for example, let's say I'm in a main function. So I'm in the main function here, and I'm calling performance, and I have machine here. It's of constant machine, some data here, and I'm passing the machine, right? Which is not compatible, but let's. Why is it complaining? Yeah, because it's missing a lot of stuff. Right. So let's say I pass. What will happen? What do you think will happen? If you remember what happened with C, it's like when I pass the machine to this one, it's what will happen is basically the compiler V8 will make another machine and send it to this function. So this function will have a new machine. It's like, imagine if we did this in C++, it will be like a new machine. This will be a new machine. If we back to the old one, if we did the machine, right? A machine in this main function, it's not the same machine in this function. They are different. If you change the value here, it's not necessary. It's not going to change. So what JavaScript does is copy to another one. So imagine if you have a lot of data and you pass it to this function, it will copy again. It'll make two copy of it. So copying. So if you want to copy, you need to copy. If you want to improve this function, you just copy the things that you want to work on. So since this function only needs sensors, we just pass sensors. Like this, we got sensor. We got rid of this one. Other thing, map, filter, reduce, what is it? All, and any type of function that when you call it, which is functional programming, that's return an array, right? It does copy. So this, when you filter sensors, it returns you a copy of sensors filtered by whatever you did with this. It does not modify the original one, right? So this here is another copy of sensors, and here is another one, because this function does the filtering twice, right? And in addition, the function was copying sensors, machine sensors, to this a new object, a new array, sensors, just for readability, because it reduced the code. So instead of calling sensors like this, instead of calling machine.sensors, the function just like so. It looked like just for, to write it faster, but actually doing copy. But you just don't see it. It just happened in the background that this will copy it for you. Because the problem is with this one, we talked about heap. Heap, when you allocate on the heap when you don't know the size of the array. Or maybe it's a dynamic array. And in JavaScript, Ruby, Python, all these, most of the time, they are dynamic arrays. They're not really fixed. So you don't know, so it does put them on the heap. So that's the problem. Other one is, since these copying, just copy, if you want to write it in a better way, you just do, sensor. What is it? Sensor of sensors, right? And you have like a active count, right? And idle count. And you basically don't need these. And you does the same stuff. So if this one is ideal, you get the point. Ideal plus. Otherwise, now in this case, you don't actually need otherwise. You could just do else, but if you have more status, and that's it. Now you don't need any of that. This function now, it just does one copy, and that's it. Instead of all the, was one copy, here's another copy of the data, here's third copy, and also was getting, if we just keep that one, it was having the machine. it was getting the machine instead of the sensor, although it doesn't need machine really. But once you understand memory, you will know that, okay, these could be improved. Now, I'm not saying this will be like a 10 times faster, but if you have a lot of these type of functions in your application, you just don't know why it's slow all of the sudden, because of all the memory copying that you're doing. Right. Well, let me check if everybody's here. Okay. Okay, so let's talk about ORM, because backend always have a problem with the ORM and when it comes to performance. I mean, GBook had 3 from the ORM. So ORM stands for Object Relational Mapping. In the database, when you request for data, the data comes like this, kind of a CSV, Excel sheet. It doesn't have like object and function and type and all the stuff when you read from the data. So to make it easier for programmer, they came up with something called ORM. So it takes the data from the database, takes it from this format, and make it as objects, similar to these. So here's an object machine that has all this type of it, right? And map it. Now, it's useful for programmers, and it's much easier to work with. So it's like you have constant machine, equal like await database, get machine, or get, find one. No, say machines, find one, and here's the ID, machine ID. And this will return you a machine. It will go read the data like this, and then put that in the object. Now, if you think about it, this must be something that's doing that in the background, okay, right? It doesn't just work by itself. How come the data come from this format and be in this object format? Like there must be some time spent on this, right? And also, other problem is we always have, which what is it? Let me look at this. No, I mean, I already know. Already have it. Okay, so we had APIs that's what's happening? We had APIs, like for example, this page takes like 11 seconds, which is unacceptable, right? It's too long. With just the users. Other one is, the user the same. All right. So what was the problem with this one? It's the ORM part. You see, when you do one-to-one join, the records comes like this way. For example, I'm joining, here's the classroom. The classroom, a classroom has a classroom level, right? And has a semester. And the semester belongs to a school. So each classroom, it's only one. For example, in last year term, the second term for this school, there is this classroom. And they have same one, but the other term. So there is like term Ningap, so right? There is no duplicate. But where is the problem? The problem is when you start joining with many to one date tables. For example, a school has like periods, but it has many. There's a many-to-many relation between a school and periods. So the difference. So if you look at this data without the periods, it look fine. You can't see them. There are no duplicates. But once you do this, you will see that, oh God, there is like all these are K1, but the why they are duplicated is because there's different periods. So what happened is like, this is like how join works. It come and for every record, for every classroom, we will see how many periods and then create for each one, each of these, when you query them. That's how like join works. So imagine if you have like a lot of tables that like many to many, or many, even many to one, or one to many the same. You will have like one record with a lot of stuff that just seems duplicated. Now, when ORM sees these, the problem, imagine now if you want to write an ORM by yourself, how would you will do? You'll take this data, you write a loop, right? And you loop through each one and see, you say, oh, this data belongs to the period. Let me put them in the period object. Right? Period you specify in your programming language, and then map them. But what if you have like so many and all like complex, you have a lot of columns, because these are, I only joined one table, many to, one to many, and I already have, look how many K1 I have. K1 I already have like what, 23. But if you have more, so imagine if you're writing the ORM by yourself, how will you do it? Right. So we had a problem with that API that was taking 11 seconds. It's because of something like it was something like this. The problem with 11 seconds, it was something like this. Simple, right? I mean, if you look at the code, maybe panha, right? It's just simple. But it was taking 11 seconds, and once I get rid of it, it was not 100 minutes, but 86 milliseconds. That's the whole different, like it's entire, I don't know, like 1,000 times faster or something like this. The problem with this one, trying to get the classroom, but the classroom, as I mentioned, has semester, and semester has a school, but the school has many users. Users. Could be teachers, could be students. And also classroom has teachers and students. So the ORM was like confusing. It just doesn't know how to map. It got confused to spend all the time here. Because also you have to think, now where is this data going to go when you read them from the database? It will go on the memory, and specifically it will go on the heap, because it's a dynamic, it's a big for to fit in the to fit on the stack, and also they are objects, so they won't fit on the stack. So they go on the heap. All the time and spent, the ORM, it's dealing with the data. Now the query was bigger. This is not the query the same as this one, but you got the right. It's the same point. So the solution that I had to make. Sorry, let's open the old one again. So the new code was like this. I was decided, okay, I only need the classroom, right? And I'll query separate. I'll do the users separately, right? Get the users and then assign them and return them the same way as this one, because this was returning a classroom. So it's the same. Now the ORM was doing it like, so this one was 10 milliseconds, but it was spending around 4.5 seconds doing this query. It's because the data is so nested. Other example is this one. Now this query is much more complicated, but it's the same problem. If you look, we have a classroom, we have inner join, so these are one-to-one. Once we start doing school periods and scoreboards, they are like nested, and also we do evaluations and purposes, a lot of table. You could join them. Technically, you could join them. And even if you get rid of the order, I tried and get rid of the order, it was still slow. The problem is with how the join works. So this was really slow. I split these into the classroom, and I did the evaluations for its own query, the scales on its own query, and everyone gets on query and then return them same as before, because we were returning like it separately. We're not returning just the classroom. We were returning each one of these as individual object. And it also was something like actually this wasn't this was gateway timeout, but now I think where is it? Do we have data here? Yeah, so it's taking 1 second. Let's see if that was, because this API creates and update. So create or find one. So yeah, so it takes around maybe a second or half a second, this API. But it was returning gateway timeout because of this query. But at the beginning, there was no problem. Later, I think the problem happened when there are more data, and that was causing it. Just the query, which technically you can. There's no problem in joining them, because that's how type ORM works. But the problem is when you have a lot of data, it's just keep going and duplicates, and it's so hard for the ORM to map them. Right. Does anyone have a question about this part? No. All right. So last one, I'll just talk about front end a little bit, because but sometimes you have a problem with the UI, and in way to do this, you could run on. I think you need React.18. But you could do that locally. You run that locally, and you start like recording, and then you just play with the thing. If you notice some slow on some of the UIs, but this is a front end like rendering, but it has nothing to do with the back end. It'll show you. Right, if you just try different API, maybe keep moving around. I don't think it track over on different pages. Right. And if you turn this, if you pause now, if you close. Okay, so it doesn't work on different pages. It just works on the current one. If you try maybe clicking here, different things. But so that's like, it's a profiling. That's how you try to get some readings on how much each component spent time rendering, stuff like this. So first one is like you have the flame graph. This is kind of in a sequence, how much is spent, but there is not much. So the school provider, for example, is in 1 second. This one like 2 seconds, 2 milliseconds. Sorry, not seconds. But the easier one is if you look at the rank chart, it will tell you how much of these was spent on. Now, if you have a problem with some of the pages, you could try the profiler and see which component is taking longer to render. Also, they have a component. So if you don't want to use the profiler, you could use the component itself and just wrap your app with the profiler component from React. And this is what onRender takes, which actually this is the callback. If you want to get the ID and actual duration, you just pass it to here and it'll set you this data back. That's if you don't want to use the browser extension. All right. Well, yeah, that's so if you want to read more about this, like Node.js event loop, it's like interesting one because Node.js has its own loop that run on V8. Also, there are different memory management strategies within these. So you could do manual allocation, but a different way. Like you kind of at the beginning or when you run your application, you ask, for example, for 2 gigabytes, and then you could use them up to you, and you don't ask for more than that. So you don't have a memory leak or you run out of memory and stuff like this. You don't have to allocate in free every time. So there are different type of strategies as well.